I've been a Bitcoiner since 2012. I've been helping with making sure that the Bitcoin node is secure. I've reported many vulnerabilities of the Bitcoin core node. And as time passes, I realized that Bitcoin needed to have layers on top, needed to have more programmability and more flexibility. And that's why in 2016, we started developing the Rootstock Sidechain, which was the first Rootstock Sidechain. So in this talk, I'm gonna give you a glimpse of what Rootstock is, but also I will try to explain why we had to create a new sidechain and cannot build on top of Bitcoin. So in this talk, first, I'm going to tell you why build on Bitcoin on the first place, right? And then a little bit about sidechains, what sidechains are. This is a very specific type of layer 2 that you can build on Bitcoin. And then we'll get a little bit of a glimpse of what Bitcoin is and what are the main capabilities of Bitcoin. Last, I'm going to show the main differences between Rootstock and Ethereum. Because if you already know how to program Ethereum smart contracts, you will see how easy it is to port them to Rootstock. So first of all, why to build on Bitcoin? So to create a new open, decentralized financial system, and that's what we wanted to do in 2016, we needed to build it on top of a store of value, a currency that allows you to be the collateral to create fiat stable coins and all kind of DeFi products. So we wanted to build on Bitcoin, and to be a store of value, Bitcoin needs to have, as a currency, needs to have certain properties, like it has to be scarce, fungible, durable, and portable. But these properties are obviously not free. This is not magic. You really need to design the network and maintain the network in a certain way to support certain properties like decentralization, censorship resistance, must be open. It's important that it's publicly verifiable for anyone with any computer. It needs to be borderless, neutral, permissionless, immutable, and of course, it needs to create a limited supply of the native token. And the Bitcoin protocol is very conservative. Like it tries to achieve all these properties in a very conservative way. If you try to make Bitcoin more private, then probably you will have to make a trade-off on one of these other properties, right? But if we take a look at Ethereum, so it's important to see that every single of these currency properties is based on certain of these network properties. So the fact that Bitcoin is a store of value is an emergent of one of these network properties. But if we take, as an example, Ethereum, which I mean, I love Ethereum for its programmability, but if we take the network as an example, if this network is able to create a store of value, we see many limitations. Like, for instance, it is really censorship resistant. If 51% of block producers are censorship transactions based on the OFAC blacklist, right? Is it really neutral? Is it really neutral if EIP 1559, which actually burns some fees, it's benefit holders and not the users? Or so each one of these properties has been, kind of attacked by its own community. For instance, it's not really immutable if the DAO incident reverted the state of the blockchain. And it's not really publicly verifiable if you need a huge computer with a 1 terabyte of space and a 16 or probably 32 gigabytes of RAM to run a node, right? So these currency properties are not free. So that's why we build on top of Bitcoin, but we need to build in layers, right? To make different trade-offs that the core Bitcoin makes, right? So this is our first layer, Bitcoin, the store of value. In the next layer, we can have different types of layers too. You can have the Lightning Network, which is a payment channel network that provides fast payments. You can have sidechains like Rootstock or Liquid that provides smart contracts. For instance, Rootstock provides stateful Turing-complete smart contracts. You can also have client-side smart contracts in the case of RGB. And you can have a separate blockchain with different language that is somehow connected to the Bitcoin infrastructure, such as stacks, right? But these are very different kinds of layer 2s. And once you have layers 2s, you can also have layer 3. For instance, over Lightning Network, you can have Taro protocol, which allows you to exchange not only Bitcoin, but fiat currency, stable coins, maybe collateralized in Bitcoin. And in the case of Rootstock, the sidechain, you can have rollups that allows you to have cheaper or faster payments. And also you can have your own payment channel network or state channel network on top of Rootstock. So essentially, you are able to build a stack of protocols in different layers. And in each one of these layers, you can have not only BTC, but you can have, of course, fiat stable coins, and you can have, in the case of Rootstock, decentralized applications. All these layers must be connected some way, and this is why bridges are created, right? So you could eventually create a bridge between Taro and Rootstock so that Rootstock assets can immediately be used from Taro and from the Lightning Network. You can create bridges between Taro and rollups, etc. So the possibilities are really endless here. The important thing is that there is one bridge that every sidechain needs, which is basically the Rootstock bridge that connects Rootstock with Bitcoin. So I will talk a little bit about these bridges, which are so important in the case of sidechains. So to make, I'm going to make a distinctions between the different layer 2s, because Rootstock is a very specific type of layer 2, which is a sidechain. And so this is the oldest definition of what a sidechain is. A sidechain is an independent blockchain. So it has its own blocks, its own mining mechanism that can securely transfer tokens internally and from and to the parent network, which in the case of Rootstock is Bitcoin. So it needs to be able to transfer Bitcoins from and to the sidechain without natively supporting a money token different from the parent native token. So this is the definition of a sidechain. You don't get to create a new token for paying transaction fees. You have to use the Bitcoin token, right? That makes a sidechain a very special beast in this ecosystem. So the main differences between a sidechain and kind of a general Bitcoin bridge blockchain would be obviously that you don't have a native token, so you have to use Bitcoin. All transaction fees are paid in Bitcoin and not in this other token. There is no block subsidy. So the consensus algorithm, everything must be orchestrated to be secure against reverts and against all kind of mined extractable value without block subsidy, which is kind of difficult, and Rootstock has made it. And it's fully Bitcoin aligned. So that's the main benefit, as using Bitcoin as a native currency. And in the case of other blockchains, it's generally very difficult to get this alignment between the communities. You may be able to, but it's generally very hard. And of course, it needs a native super secure bridge, right? Because since your whole blockchain depends on this connection with Bitcoin, the Bitcoin must be secure. And in the case of Bitcoin bridge blockchain, you can have several lower security bridges. Maybe some of them fail, and they can compete. But this is not the case of a sidechain. The sidechain, by definition, needs a very secure bridge. So now that you understand the importance of sidechains and the difference of sidechains, let's dig in what Rootstock is. So Rootstock was the first Bitcoin sidechain. It was launched in 2018, but the project started actually in 2016, and it took us 2 years of different test nets to reach the point of launching Rootstock. It is merge mined with Bitcoin. So RSK blocks, Rootstock blocks are produced by the Bitcoin miners, and is secured by more than 51% of the Bitcoin hash rate. So the majority of the Bitcoin hash rate is securing Rootstock at any moment. It implemented the first bridge, and it's the first hybrid SPV federated bridge. And one of the properties of this bridge is that it was designed to be drive chain compatible. So if at any time in the future, and we really expect, and we are pushing this to happen in the following years, If the Bitcoin community implements a drive chain, then from the Rootstock side, we will be able to switch our peg and to become a fully decentralized layer 2 and sidechain of Bitcoin. Another property, it is EVM compatible. So you take your Ethereum application, you can compile it and deploy it on Rootstock, maybe without any change or maybe with very little changes, and you have it running on Rootstock. And that's a huge pro because we know there are many developers that are already used to working with Ethereum. It has a very rich DeFi ecosystem. Like you have decentralized exchanges, lending, borrowing, all kind of DeFi products that you can plug into. And of course, the native token is Bitcoin, right? So you pay transaction fees in Bitcoin. So as I told you, every sidechain needs a bridge. And in the case of a sidechain, it's called a two-way peg. So this is the bridge that I'm going to talk about, the one that connects Rootstock with Bitcoin. And the RSK bridge evolved from a federated bridge, which means that a federation of functionaries, each one of them holds a private key, and this private key is part of a multisig, and this multisig controls the funds that are sent to the Rootstock sidechain. But it evolved, and it evolved in something we call the PowPeg. And the PowPeg is much more than a federation, and I'm going to talk more about in the next slide. So what do we want for a two-way peg? We want it to be secure, trust minimized, decentralized, censorship resistant, capital efficient, Bitcoin aligned, and fast and autonomous. And the problem here is that you cannot get all these properties at once, because Bitcoin protocol does not allow you to do to validate consensus of foreign blockchains. So basically, we have to live with the level of extensiveness that Bitcoin allows. So we've built a bridge that is secure, is trust minimizes, is censorship resistant, is capital efficient because there is no other collateral. It's Bitcoin aligned. You can have fast and autonomous peg-ins and peg-outs, but obviously we cannot make it fully decentralized until we get the drive chain implemented in Bitcoin itself. So this is how the bridge looks like. Basically, when you do a peg-in, you send your Bitcoins to a multisig that is controlled by HSM devices. And this federation of HSM devices, each one of these devices holds a private key. And this device will never, ever allow you to either see or force the use of one of these private keys, right? Each one of these devices is following RSK consensus, so it's actually validating the hash rate of the RSK blockchain, right? So even if I have full control of this box, I won't be able to have access to this private key. And this HSM federation works as a K out of N multisig. So there are currently 11 devices, and you need 6 devices to be in consensus and to be able to perform a peg out. The fact that this PowPeg is a hybrid PowPeg is very interesting, because when you do a pegging, you actually send the funds to the devices, but the pegging process is fully decentralized. So you can send this information about the blocks that confirm your payment or your transfer into the smart contracts in the Rootstock blockchain, and that smart contracts will issue the smart Bitcoins, the RBTC, for you. So the pegging process is fully decentralized. Even if it's fully decentralized, you don't need to do this yourself, because the pegnatories, which are the functionaries that hold each one of these boxes, will inform the Rootstock blockchain for you. So you don't have to do this, but eventually you can do this by yourself. The peg-out process is the opposite, but now it requires the involvement of the HSM devices. So you send RBTC to a smart contract on the Rootstock blockchain, and then the Rootstock, these smart contracts called the bridge smart contracts will create a Bitcoin transaction and will send this Bitcoin transaction to the devices to sign. Once the majority of them sign, the transaction will be ready to be broadcast on the Bitcoin network, and you have your Bitcoins back on the Bitcoin network. The process of pegging in and pegging out, there is two ways of doing this. Either you use the more secure process, which takes more than a day of confirmation blocks. It's very secure, but there is a layer on top of this protocol, which is the flyover protocol, which allows you to do this in just a few block confirmations. This protocol will be, I mean, the protocol is already implemented in the Rootstock blockchain, but I think that the front end needs some finalization. So you will see this very soon for you to use. And in terms of security, the PowHSM devices are using the most secure technology to protect the private key, which is basically the secure elements. It's more secure than the security enclaves of general purpose processors like SGX or Trust Zone, and it's more secure than having a tamper-proof box having some standard microcontroller. So we are using the best possible technologies to secure the private keys, and the firmware is open source. And also these devices perform public attestation, so you can actually validate that each one of these devices is running the exact firmware that protects the private key. So to summarize about this PowPeg system, it has a defensive design. So even if one of the devices or one of the layers fail, there is always another layer that is protecting that layer. It has consensus enforcing HSMs, so you cannot force the device to do anything without a huge amount of hash rate backing up your commands. It is proof of work secure. It's fully auditable, and the full coordination process for pegging in, pegging out, and dynamic reconfigurations of the PowPeg is fully transparent on chain. And obviously, it's as I mentioned, it's censorship resistant. Now, this was the main component of Rootstock in terms of technology, right? Not in terms of how you use it, but in terms of the technology behind Rootstock. The other huge component is the merge mining part, right? So you know that Bitcoin hash rate it's been more than 200 exahash per second right now. It's huge, and as I mentioned, more than 50% of this hash rate is currently securing Rootstock. So how this merge mining process works? So essentially, there is probably about Bitcoin transactions, so I'm gonna go this very quickly, but there is a Bitcoin transaction called the Coinbase transaction, or sometimes called the generation transaction. That is the first transaction in the list, and this transaction you can put as many outputs as you want, and if you put one particular output having an op return opcode with the specific tag, which is the RSK block tag, and you add to it a hash of a RSK block, you can actually link a Bitcoin header with univocally with the Rootstock header. So basically, every time you are mining the Bitcoin header, you are mining the Rootstock header too. So once you have this hash embedded in a RSK block header, you can create a merge mining proof that in a very succinct way allows you to prove that those things are connected. Like the Bitcoin header is connected with the RSK block header in a univocal way, right? So you need a tree membership proof, a Merkle inclusion proof. You need a SHA-2056 mid-state, the tail of the Coinbase transaction, and a lot of pieces. But you actually finally have a small message, less than 1 kilobyte, that proves that these two headers are connected, right? And then you start hashing, right? You start mining, as always. You take your Bitcoin header, you increment the nonce until you get a hash digest with a certain number of zeros, right? But this is where the things differ. You can find a hash digest having the difficulty of a Bitcoin block, or you can find hash digests having lower difficulty, but higher than the target difficulty of the Rootstock block. And in that case, you have created a valid Rootstock block. If you create a valid Bitcoin block, it will also be a valid Rootstock block because its difficulty is higher than the Rootstock difficulty. So the same process you use to mine one Bitcoin block, you use to mine the Rootstock block. And most mining pools are currently using this mining pool software that allows them to do merge mine. So if you take a look at how the different blockchains are created, the Bitcoin block is obviously a chain of Bitcoin headers, and the Rootstock blockchain is a chain of Rootstock headers, but each one of these Rootstock headers is connected through this merge mining proof with a Bitcoin header having a specific target difficulty, which might not be the same target difficulty as a Bitcoin block, but it's approximately 20 times lower. So if we take a look at these probabilities, these difficulties, Bitcoin block is created every 10 minutes, and the approximate probability of finding one of these blocks is 2 to the 66 power, and the RSK block, which is produced approximately every 30 seconds, it's almost as hard as a Bitcoin block to produce, like it's 2 to the 71 power, okay? And below that is the mining pool share. If you know a little bit of how mining pools work, there are certain headers that are mined at lower difficulty that are used for accounting, right? And this has a very lower difficulty than the Rootstock block. So essentially, we don't have to stress the Bitcoin mining network for mining Rootstock blocks. Okay, now I mentioned that Rootstock is Ethereum compatible, but there are certain differences that you need to know. First, what is really compatible between the networks? So developer tools all are the same. You get the same compiler, the same Solidity compiler, the same IDE. If you want to use Remix, or you want to have your local compiler, the same debugger, same front ends, same APIs. In terms of user interface, what the user sees is the same. Like, you have the same terminology. You can talk about gas price, block gas limit. Transactions are, the transaction format is the same kinds of addresses, while addresses have a different checksum. So not to mistakenly use a Rootstock address on Ethereum and vice versa, but it's almost the same. You can have the same infrastructure services because Rootstock supports the Web3 JSON RPC interface. So any Explorer or anything you connect to Web3, it would probably work. But from that point below, there are certain differences. Like, if you want to hack into the node, you will see that the network messages are slightly different. Also, the cost of the different codes or opcodes are different because Rootstock is optimized in certain ways. So certain opcodes are cheaper, certain other are more expensive. So you still have to check if you are doing very, tweaking the gas cost of certain code, then you may take a look at the different costs. And the internal data structures of a node are really different. And this is very important because we've made, since the beginning of Rootstock, we've created a data structures that are more efficient to scale. So these are the main differences. Like, Ethereum has switched to proof of stake. We've obviously stayed on proof of work. We use the DCore protocol, which is a variant of Nakamoto consensus. It is merged mined with Bitcoin, and it is using the Ghost chain selection rule, same as Ethereum before switching. We don't have a block subsidy. Well, Ethereum does have a block subsidy. And I think that the only important difference here is the time between blocks, which in Ethereum currently is fixed at 14 seconds if there's no block skipped. And in the case of Rootstock, it's approximately 33 seconds, while the miners have the option to lower this down to, I think, 16 seconds. Currently is 33 seconds of block interval. There are several proposals in the Rootstock RSK-IP repository to increase the rate of Rootstock blocks up to having 5-second blocks. You can check in this repository. And as I mentioned, internally, the data structures of the node are different. Ethereum stores everything in millions of different tries, right? Every smart contract in Ethereum has storage, and all the storage is stored in different try. In the case of Rootstock, we have a single data structure called the unit try that stores everything. This makes the node much more efficient in handling snapshots, handling moving to any block, and so garbage collection, everything is simpler having a single tree containing all information. And another key difference is in Ethereum, Ethereum uses a radix 16 try and three kinds of nodes, while RSK uses a binary trie, very simple, single type of node. And so it's also very efficient for stateful, stateless proofs and all kinds of advanced features. So I'm reaching the end of the presentation. So we built Rootstock on Bitcoin because we believe Bitcoin is a long-term store of value. And we want Rootstock, we built Rootstock to create a new, more open, decentralized financial system that can, can serve everyone in this planet. As I mentioned, Rootstock is a sidechain. A sidechain needs a bridge, and this bridge allows you to send Bitcoins from and to the Bitcoin network. We don't have an native token. You are stuck for good or for worse, I think for good, with Bitcoin. And that means that everything that's built on Rootstock, it's really focused on real world use cases. I think there's very little pure speculation, because having this using Bitcoin token that you cannot inflate, I think it's a huge benefit. Rootstock is compatible with Ethereum, and our consensus, the block production is based on merge mining, having more than 50% of Bitcoin miners engaged. And the peg is highly secure with this set of HSMs. And I encourage you to build on Rootstock, to try it. And I think in a couple of hours, Alejandro Caballero will be doing presentation of the different tool set, the compilers, everything you need, the links to the how to download the node, everything to get started. And I just want to add to this. I think this is very important, that this year there will be a strategic grant program to provide funding for developers, researchers, builders that really want to make a strategic impact on the growth of the Rootstock and Reef ecosystem. So there will be waves of grant, 3-month grants with a certain timelines, and each one with a certain theme. And there will be an external voting committee so that it's completely fair. And we are aiming to have 100 grants given in this year, and about 2.5 million of funding waiting for this program. So I think this is great. I hope you take this opportunity. Okay, so thank you very much. And this is